Friends, in this article, we will study the principle of launching a satellite, concept of open and closed orbits. For launching a satellite, it is necessary, the first condition is, it must be taken to a certain height. You see, the A is a point above the surface of the earth. I give some horizontal velocity to some object projectile. It falls at point 1. If I increase the horizontal velocity, the trajectory will be followed like this way and the satellite will fall at point 2. It will strike on the earth. Similarly, if I further increase the horizontal velocity from point A at a certain height, this will strike at point 3. Now, at a certain value of the velocity, when the object is projected, it is given a horizontal velocity. What will happen? It will continue to move in a circular path. That is, it will be in a condition of free fall. It will always try to hit the earth, but it will be missing the hit. That velocity is known as the orbital velocity. There are two types of the orbits. The first orbits are known as they have the shape like you can say hyperbola. Hyperbola are known as the open orbits. In open orbits, the total kinetic energy of the satellite is 0 and it will never follow the same path. It will continue to rise in the above direction in increasing radius and will never come to the same point. Those are known as the open orbits. In closed orbits, the satellite will come to the same point. It will repeat the motion. So this is the circular motion, and for a circular motion, it is necessary that there might be some centripetal force. So first we must know there are two conditions for launching a satellite. First, it must be given some escape velocity. That is, it must be given some escape velocity so that above the surface of the earth, and then it must be projected with some velocity. So the two conditions are that first the object is to be taken to a certain height, then second it is given some horizontal velocity so that it may not hit the surface of the earth and will continue to rotate in a circular orbit. That orbit is known as the stable orbit, and the velocity, corresponding velocity, is known as the orbital velocity. So orbital velocity is defined as the velocity required to put a satellite into Earth's orbit. Now, as I have already said that this is Earth, this is radius of the Earth, and let me say that this is the height of the satellite, h, and the satellite is moving like this. Centripetal force is there. So, centripetal force is provided by the gravitational force of attraction between the Earth and the satellite. This is our satellite having mass small m. So, F is equal to, you can say G, this is m upon, you can say R plus H whole square. And this is gravitational force. The centripetal force is centripetal force. It is equal to m v naught square upon R plus H. In equilibrium, both the forces are equal, or you may say that centripetal force is provided by the Newton's gravitational force. So equating these two, that is m v naught square upon R plus H, it is equal to G m small m, this is R plus H whole square. This small m cancel out, R plus S goes, so you are left with V naught is equal to G m V naught square लिख दीजिएगा upon R plus H. Now V naught is equal to G m upon R plus H under the root. Now if the satellite is very close to Earth, then H is equal to approximately equal to 0, and therefore you can say V naught is equal to Gm upon R. But you know the relation between small g and capital G, that is Gm can be written as, this is gravitational constant, this is mass of Earth, that is Gr square upon R. 1 R goes off and the orbital velocity is equal to Gr under the root. If we put the values, the value comes out to be equal to V0 is equal to 7.92 kilometer per second. You can convert it. You can write the value, you can calculate it. First it will coming into the meter per second, then you will convert it into kilometer per second. This is the orbital velocity. Now let us see the relationship between. You know that escape velocity, it is equal to root Gr. And for simplicity, I am writing like this way, very simple thing, and escape orbital velocity is equal to Gr. So Ve upon escape velocity upon orbital velocity, it is equal to root 2 Zr upon Gr. This gets cancelled, and escape velocity, it is equal to, escape velocity is equal to twice the orbital velocity. You can simply find out the escape velocity if orbital velocity of a satellite is given. This is how we can see the relation between escape velocity and orbital velocity, and this is the expression for the orbital velocity of a satellite. Again, I remind the concept of the open and closed orbits. Open orbits are those whose trajectory is hyperparabola or parabola, and those orbits which are having different shape other than the hyperbola or parabola, that is elliptical orbits, are known as the closed orbits. The orbits which are elliptical in shape are known as the closed orbit. और जैसा मैंने आपको बताया है कि ओपन ऑर्बिट के अंदर क्या होगा, साइज हाइपर ट्राजेक्टरी हाइपर पैराबोला होगा या पैराबोला होगा, and the satellite will never come to the original position with the same speed, but it will continue to rise in increasing radius. That will I will discuss in the energy, total energy of the satellite. In the next article we will be dealing with the time period. हमने भी velocity कैलकुलेट कर ली है, height of the satellite and angular momentum. Thank you.